Alright, in this video we're going to talk about three different ways that you can find the equation of a quadratic from some givens. So these are quadratic functions, so like y equals f of x, so parabolas basically. So the first option is we can use y minus k equals a times the quantity x minus h squared, like vertex form, transformational form, standard form, a lot of options for what you might call that. And you're going to use this when you know the vertex, which is h comma k, and you know another point. So we're going to use that in that case. A second option is y equals a, the quantity x minus r1 times the quantity x minus r2, where r1, r2 are the roots of the quadratic. So if you know the ordered pairs, r1, 0, r2, 0, and then you need another point to be able to figure out what a is. And then the third option, which is actually by far the most labor intensive, is where we just know three random points. And so what we do is we use y equals ax squared plus bx plus c. We end up with a system of three equations and three unknowns, and then we solve it by whatever method we prefer. So let's take a look at one of each. So if we know the vertex is 3, negative 2, and we know that it passes through the point 8, negative 5, we dive right in using vertex form. I mean, that's why it's called vertex form. So start out like that. I like to write down vertex form and then fill in the blanks, kind of. Well, they're not blank, but fill in the appropriate places. So I get y plus 2 equals a, the quantity x minus 3 squared. So the plus comes from minus negative 2, becomes plus 2. Now I'm going to use the point 8, negative 5, so I'm subbing in for x and y. So negative 5 plus 2 equals a, the quantity 8 minus 3 squared. Do a little bit of math. Negative 3 equals 25a, which means that a is negative 3 over 25. And we can write the quadratic. So we get y plus 2 equals negative 3 over 25, the quantity x minus 3 squared, and we're done. You usually leave your answer like that, certainly if it's in vertex form. That's one of the more convenient forms to have. Let's take a look at another one, so number 2. In this case, we know negative 3, 0, 5, 0, and 7, 1. So we actually know both of the zeros of the quadratic, so we're going to go ahead and use this form. A, the quantity x minus r1, the quantity x minus r2, and so now it's just plugging in. So y equals a, so I end up with plus 3 because minus negative, and then x minus 5. Now I'm going to plug in the point 7, 1. So 1 equals a times 7 plus 3 times 7 minus 5. 7 plus 3 is 10, and then 7 minus 5 is 2, so that's 20. 1 equals 20a, which means that a is 1 over 20. And I'm just going to write my answer like this. Y equals 1 over 20. X plus 3, x minus 5. So that is a quadratic that passes through those points, so it satisfies it. I would say more often than not, you're probably going to have to put that in vertex form or expand it and put it in general form, but I'm going to leave that because I'm making the video. So let's do another one. So we have 2, negative 1, 5, 2, and 6, 5. So three random points. So this is usually kind of the worst one. So I have y equals ax squared plus bx plus c. And now what I do is I take each point and I plug it in. So I'm going to plug in 2, negative 1, and that's going to give me 4a plus 2b plus c equals negative 1. Now I have 5, 2. So I'm going to plug that in, get 25a plus 5b plus c equals 2. And then 6, 5 gives me yet another equation. And there you have it, 3 equations and 3 unknowns. You can solve that however you want. I'm going to solve it using Cramer's rule because I recently had to use that again. And I hadn't used it in kind of a couple of years, and I sort of like it. So if you're not familiar with this, you might want to look up either my video or another video on how to use Cramer's rule. It's pretty neat, though. It all comes down to using determinants. So I'm going to have to calculate some 3 by 3 determinants in this case, and I'm going to do that more or less in my head. I'm expanding along the first row, so if you don't know what I'm talking about, this is pretty confusing. But anyway, let me do this. Okay, so I get d is negative 12, and then if you remember Cramer's rule, I have to calculate d sub a, d sub b, and d sub c, so let's do that. So d sub a, you can see I replaced the first column, 4, 25, 36 of d, with the constants, the things that each equation was equal to, so negative 1, 2, and 5. And then I'm going to calculate this across the first row. I always go across the first row. You can actually go across any row or column, but then you have to remember more things. So I just find it convenient to always go across the first row. D sub b, I'm going to go back to the original d and replace the b column. So all the coefficients of b are getting replaced with the constants. Expand across the first row. So I get this. You might be thinking, why am I solving it this way instead of some other way, which might have been easier? I don't know. You just want to practice. So do this. I mean, obviously the easiest choice is to use a calculator. And then what I do is I do d sub a over d sub b over d, and d sub c over d to get a, b, and c respectively. So that's where these numbers are coming from. So that 1/2 is -6 over -12, or d sub a over d. That -5 over 2 is d sub b over d, and then 2 is d sub c over d. So I know a, b, and c, so I'm actually kind of done. So this answer I would almost certainly leave like this. But anyway, that's 3 different things you can do, 3 examples. I hope you found this helpful, and good luck.